members, distinguished guests, ladies and gentlemen, can we all put our hands together for the university, please? Thank you very much. Today's inaugural lecture is titled Unraveling the Coupled Heat and Water Flow Phenomenon. My non-invasive voyage into the subsurface domains. And the lecture is to be delivered by no other person than an eminent expert in solid earth physics, a fellow of the Indian Society of Earth Scientists, and the current Deputy Vice-Chancellor Academic, Professor Olukayode Dewumi Akinyemi. Professor Akinyemi is of the Department of Physics, College of Physical Sciences in this great citadel of learning. In this building today, we have some golden fishes, and one whom this building is named after. Someone very dear to this university, the fourth substantive Vice-Chancellor of the Federal University of Agriculture, Abeokuta, Professor Oluwafemi Balogun. Professor Balogun is widely known in the university as the architect of the modern FUNAB. Dear distinguished guests, ladies and gentlemen, please let's give him a round of applause once again. A better applause, please. Thank you very much. Thank you, sir. With us in this ceremonial Oluwafemi Balogun ceremonial building is another golden fish and a bosom friend of the first substantive Vice-Chancellor. He is the former Vice-Chancellor of the Federal University of Technology, Akure, Professor B.C. Balogun. Can we get a round of applause for him, please? We also have in our midst this afternoon another golden fish, a former Vice-Chancellor of the great University of Ibadan, Professor Femi Bamiro. Thank you very much. You're welcome, sir. Also this afternoon we have Emeritus Professor Godwin Ehagwere from the University of Ibadan. You're welcome, sir. We also have with us this afternoon from Parawe, South Africa, in the University of KwaZulu-Natal, Professor Tosin Wemimo. Thank you very much, sir. You're welcome to the Federal University of Agriculture, Abeokuta, the best university in the whole of Africa. Best University of Agriculture. Thank you. Thank you very much, sir. We also have with us this afternoon a member of council of the University of Ibadan, Professor James Adegoke. You're welcome, sir. Thank you, sir. In this Oluwafemi Balogun ceremonial building are former deputy vice chancellors, a slip of protocol there. I have in this hall a former acting Vice-Chancellor, Professor Olukayode Dewumi. Can we give him a round of applause, please? Thank you. We have with us this afternoon two former Deputy Vice-Chancellor academic in the person of Professor Clement and Oluwafemi Eromesele. Can we give them a better applause, please? Thank you. In this hall also, we have from Faraway College of Food Science and Human Ecology, COLPHYS, Professor Folake Enjo. Also with us is Professor Julia Eniolorunda. Thank you. We have in our midst this afternoon Professor James Ogutuashe. You're welcome, sir. A former Deputy Vice-Chancellor Development is just entering the hall, Professor Clement Adeofun. Just entering the hall is our immediate past Deputy Vice-Chancellor Academic, Professor Christian Ikeobi. Just entering the hall also is Professor Steve Afolami and Professor Caroline Afolami. Can we get an applause for them, please? This university, as earlier stated, had a strong global ranking. We have in our midst this afternoon a former commissioner from Faraway, Oyo State, just near Oyo State. As earlier stated, you are all welcome to the 89th Inaugural Lecture of the Federal University of Agriculture, Abeokuta. The lecture is titled Unraveling, the Coupled Heat and Water Flow Phenomenon, My Non-invasive Voyage into the Subsurface Domains. Dear distinguished guests, ladies and gentlemen, It is my honor to recognize the presence of the sixth substantive Vice-Chancellor of the Federal University of Agriculture, Professor Felix Kolawole Salako. Can we give him a round of applause, please? We have in our midst this afternoon a former commissioner in Oyo State, very near here, and one of our former member of staff, Professor Adeniyi Oluwafemi. Can we give him a round of applause, please? We have in this hall Professor Kingsley Eche, a professor of animal nutrition and physiology. Also the principal investigator, feed ration formulation project with Global Methane Lab. He's also the head of division, animal production and fisheries of IRAD, Cameroon. Dear distinguished guests, ladies and gentlemen, please join me in applauding Professor Kingsley Eche. Sorry for the sleep, it's Echu. Professor Kingsley Echu. Dear distinguished guests, ladies and gentlemen, please, when the procession is filing in, we are all expected to stand in reverence to the procession. Thank you very much. And then we are also expected to clear the hall. Please, may we all stand. The procession is filing in, please. Thank you. May we all stand, please. The procession is filing in. Thank you. On the procession is the Director, Institute of Food Security, Environmental Resources and Agricultural Research, Professor Alaba Jolaosho. Also in that procession is the Director, Student Industrial Work Experience Scheme, Professor Adeyemi Akinyemi. I beg your pardon. Also the Director, Community-Based Farming Scheme, Professor Sunday Adigbo. Director, Agricultural Media Resources and Extension Center, Professor Jacob Olaoye. We have the Dean, College of Biosciences, Professor Olukayode Kehinde. Dean, College of Physical Sciences, Professor Taufik Akinwale. Dean, College of Animal Sciences and Livestock Production, and also the Chairman of Committee of Deans and Directors, Professor Olushijishewande. We have the principal officers filing in now, the University Librarian, Dr. Aboyomi Owolabi, Acting Bossa, Mr. Olukayode Oshinuga, Acting Registrar, Mrs. Oluwatoyin Morfa Daudu, the Deputy Vice-Chancellor Development, Professor Kola Adebayo, Deputy Vice-Chancellor Academy, Professor Olukayode Akinyemi, and the 89th Inaugural Lecturer, the Vice-Chancellor, Professor Olushola Babatunde Kehinde. Ladies and gentlemen, the national anthem, please.
Shall never be in vain. To serve with heart and mind, one nation bound in freedom, peace and unity.
Anthem, please. all be seated, please? Thank you. Thank you very much. Dear distinguished guests, ladies and gentlemen, you are all welcome to the 89th Inaugural Lecture of the Federal University of Agriculture, Abeokuta, the best University of Agriculture in Africa and the 7th best globally. Can we get a better applause for that, please? Thank you very much. Today, we are having the 89th Inaugural Lecture titled Unraveling the Coupled Heat and Water Flow Phenomenon, my non-invasive voyage into the subsurface domain. Dear university community members, ladies and gentlemen, it is my honor this afternoon to introduce to us our own Vice-Chancellor, Professor Olushola Babatunde Kehinde. The Vice-Chancellor is a Fellow of the Genetic Society of Nigeria, Fellow of the Institute of Health and Safety, and also Fellow of the Agricultural Society of Nigeria. Can we get a better applause for the Vice-Chancellor, please? Thank you. With the Vice-Chancellor this afternoon, there's going to be a slight change in the protocol this afternoon because the person that I'm supposed to call is wearing two caps. But right now, I'm going to be introducing to us the Deputy Vice-Chancellor Development, Professor Kola Adebayo. Also on the top table this afternoon is the Acting Registrar, Mrs. Oluwatoyin Morufat Daudu. The Acting Bursar is also with us this afternoon, Mr. Olukayode Oshinuga. The University Librarian is Dr. Abayomi Owolabi. Thank you. We have with us this afternoon the Dean College of Animal Science and Livestock Production, who doubles as the Chairman, Committee of Deans and Directors of this great citadel of learning, Professor Olushiji Showande. We have the Dean College of Physical Sciences here present, Professor Taufik Adewale. Also on this other side of this divide is the head of Department of Physics, Professor Itunu Okeyode. Dear university community members, ladies and gentlemen, today we are all gathered here in this expansive Oluwafemi Balogun Ceremonial building to listen to the fascinating and interesting scientific journey of our 89th inaugural lecturer, which centers on the nexus between unraveling the coupled heat and water flow phenomenon. The lecturer will take us through this voyage into the subsurface where he unravels the mysteries of this critical phenomenon, exploring innovative methods and revealing new insights that have far-reaching implications for our understanding of the earth systems and our sustainable future. Distinguished ladies and gentlemen, dear university community members, please join me in welcoming the university's 89th inaugural lecturer from the Department of Physics in the College of Physical Sciences, an eminent expert in solid earth physics, a fellow of the Indian Society of Earth Scientists, and the current Deputy Vice-Chancellor Academic, Professor Olukayode Dewumi Akinyemi. Thank you very much. Greatest Funabite. Thank you very much. The lecture is titled Unraveling the Coupled Heat and Water Flow Phenomenon, My Non-invasive Voyage into the Subsurface Domains. With the permission of the Vice-Chancellor, sir, I would like to recognize the family members of the inaugural lecturer, led by Dr. Mrs. Akinyemi. Can we give her a round of applause, please? All the deans, directors, heads of departments, and heads of units, we acknowledge your presence. Can we give you a round of applause, please? Thank you. Members of the ceremonial committee led by Professor Adegoke Bakare, can we give him a round of applause too? Thank you, sir. Also with the permission of the Vice-Chancellor, let me quickly recognize our former Vice-Chancellor, sir. We have with us in this hallowed hall, one who this hall is named after, the fourth substantive Vice-Chancellor of this great citadel of learning, Professor Oluwafemi Balogun. He is widely known on this campus as the architect of modern FUNAB. Can we give him a better applause, please? Thank you. Also, we have in this hallowed hall the immediate past Vice-Chancellor, the sixth substantive Vice-Chancellor of this great university, Professor Felix Kolawole Salako. He's widely known on this campus as Mr. Project. Can we give him a better applause, please? Thank you. Also, we have the former Vice-Chancellor of University of Ibadan, Professor Femi Bamiro. We also have in our midst this afternoon, Mr. Vice-Chancellor, sir, a former Vice-Chancellor of the Federal University of Technology, Akure, and also a bosom friend of the fourth substantive Vice-Chancellor, Professor Bisi Balogun. The Vice-Chancellor will be doing the recognition later on. It is now time. Yeah, the Vice-Chancellor will do that. Thank you very much, sir. It is now time to listen to the address of the Vice-Chancellor, Professor Babatunde Kehinde, as I welcome him respectfully to the microphone. Thank you very much, sir.
Please let's have our seats. Please let's have our seats. Kulu Kulu, thank you very much. Distinguished ladies and gentlemen, please, before I go ahead, let me continue where the acting head of the Public Relations Unit stopped. We are delighted this afternoon to have in our midst several former vice-chancellors and chief executives of universities in our midst. He has introduced the fourth substantive vice-chancellor, Professor Oluwafemi Balogun. He has introduced my immediate predecessor, the sixth vice-chancellor, substantive vice-chancellor of our university, Professor Felix Kolawole Salako, as well as Professor Femi Bamiro, as well as Professor Bisi Balogun. But seated in our midst is the former Vice-Chancellor of Lagos State University. That state university that at one time was the best state university in Nigeria, and my own personal friend, Professor Olanrewaju Adigun Fagbohun. Professor Fagbohun is in our midst. Thank you very much. You're welcome, sir. He hosted me in that citadel of learning for 3 years. Thank you very much, sir. We also have the Foundation Vice-Chancellor of Augustine University in Epe, Professor Steve Afolami. Professor Afolami, you are welcome, sir. Our own Professor Afolami. There's a tendency to want to claim him all the time and not acknowledge that he was the foundation Vice-Chancellor. Okay, you are welcome, sir. We also have a former Vice-Chancellor of Landmark University. Yes, Landmark University. My own dear brother, Professor. Now, I want to get his initials right. TMA Olanyoju. TMA Olanyoju. You are welcome. We also have the acting Vice-Chancellor of our university, Professor Ololade Adeduro Enikumeyin, on seat. And of course, I'll come back to the recognitions, but we have an array of deputy Vice-Chancellors of this university. In fact, it's indeed a great occasion. Thank you so very much. And of course, former members of the University Governing Council. I can see them all here. Thank you very much. At this juncture, distinguished ladies and gentlemen, may I invite the 89th Inaugural Lecturer of our university to please stand beside me here and remain standing. The Deputy Vice-Chancellor Development, the Acting Registrar of the University, the Acting Bossa, the University Librarian, the Inaugural Lecturer, and the Deputy Vice-Chancellor Academic of our institution, Professor Olukayode Dewumi Akinyemi, the Dean, College of Physical Sciences, other deans and directors here present, the Head Department of Physics, members, other heads of departments and units, members of the University Senate, all academic and non-teaching staff, all special guests and friends of the university, members of the family and friends of the inaugural lecturer, gentlemen of the press, distinguished ladies and gentlemen, and the greatest Funabites, of the greatest Funabites, of the greatest Bagba, Bo, Bo, Kulu, Kulu. Thank you very much. It is my pleasure to welcome you all to the 89th edition in the series of inaugural lectures of the Federal University of Agriculture, Abeokuta. Today's inaugural lecturer, Professor Olukayode Dewumi Akinyemi, was born on December 5, 1972, to the family of late Chief Isaac Ade Akinyemi and Mrs. Felicia Adedoyin Akinyemi, both from Ado-Awaye in Oyo State. Professor Olukayode Akinyemi holds the Bachelor of Science Physics and the Master of Science in Solid Earth Physics in 1994 and 1998, respectively, from the prestigious University of Ibadan. He had his other training programs at the International Center for Theoretical Physics, Trieste in Italy, on geophysical fluid dynamics and shallow water dynamics between 1996 and 1998. Professor Akinyemi obtained the Doctor of Philosophy PhD degree in Solid Earth Physics in 2004 from the University of Ibadan, after which he proceeded. Thank you. After which he proceeded to the Porous Media Thermal Systems Laboratory of the Pontifical Catholic University of Paraná, Brazil, between 2006 and 2007 for his postdoctoral fellowship. Professor Akinyemi joined the services of the Federal University of Agriculture, Abeokuta in 1998 as an assistant lecturer and rose through the ranks to become a professor on October 1st, 2013. He was on a Dutch research fellowship to the Eco-Hydrology Department of the Wageningen University and Research Center, Wageningen, Netherlands, between 2012 and 2013. In 2015, he obtained the Association of African Universities Fellowship as a visiting professor, which was utilized at the Department of Earth Science, School of Physical and Mathematical Sciences, University of Ghana, Legon, Ghana. He had a sabbatical stint at the Department of Physics, Lagos State University, Ojo, between 2017 and 2018. He has held a number of positions in the university system, including Assistant Coordinator, Pre-Degree Unit from 2002 to 2004, Coordinator, Department of Physics, College of Natural Sciences, 2007 to 2008, Acting Head, Department of Physics, College of Natural Sciences, 2008 to 2009, Director, Center for Internationalization and Partnerships, 2009 to 2012, Director, Research Grants Management Center, 2012 to 2014, Director, Academic Planning, 2014 to 2017, Head, Hydrology and Climate Change, Africa Center of Excellence, from 2013 to 2017, Center Leader, Africa Center of Excellence in Agricultural Development and Sustainable Environment, from 2018 to 2024, and the Deputy Vice-Chancellor Academic of our great university from January 5, 2024 till date. At the university level, Professor Akinyemi has served in close to 40 committees, some of which are Member University Senate from 2008 till date, Member Senate Committee on Examinations Results from 2010 to 2016, Member University Admissions Committee from 2014 to 2017, Member Curriculum Committee, Member A&PC, Member University Ranking Advisory Committee, Chairman Committee on External Engagement and Fundraising from 2023 till date. At the national level, Professor Akinyemi has also served in different committees, including National Research Fund Screening and Monitoring Committee, National Advisory Committee on the Evaluation of the TETFund Centers of Excellence, and the National Food Security Strategic Plan Committee. On the international scene, Professor Olukayode Akinyemi has been a member Early Career Selection Board for the Organization for Women in Science for the Developing World from 2018 till date, among others. He's currently serving in some international journals as editor, Advances in Geological and Geotechnical Engineering Research, a reviewer for International Journal of Heat and Mass Transfer, reviewer for Environmental Earth Sciences, reviewer for Geography and Sustainability. Professor Akinyemi has supervised over 200 undergraduate projects, 8 Master of Science dissertations, and 9 PhD theses. He has, to his credit, over 80 scientific publications. Professor Akinyemi has conducted external examinations and professorial assessment in 15 universities, including the University of Ghana, Legon. He has carried out accreditations and quality assurance monitoring in 16 other universities in Nigeria. He was the panel chairman appointed by the National Council for Higher Education of Namibia for the international accreditation of the Department of Physics and Material Sciences, University of Namibia in Namibia from October 3 to October 5, 2022. Professor Akinyemi belongs to a number of academic and professional bodies, including Fellow, Indian Society of Earth Sciences, Member, Nigerian Institute of Physics, Member, American Geophysical Union, Member, West African Research and Innovation Management Association, and a Fellow, Association of Applied Information Management Professionals. Our inaugural lecturer of today is married to Dr. Oluwafemi Akinyemi of the Department of Pure and Applied Botany, and the marriage is blessed with 4 children. Distinguished ladies and gentlemen, it is my pleasure to invite Professor Olukayode Dewumi Akinyemi from the Department of Physics, College of Physical Sciences, to present his inaugural lecture titled Unraveling the Coupled Heat and Water Flow Phenomenon, My Non-invasive Voyage into the Subsurface Domains. Thank you so much for listening, and God bless you all.
The Vice-Chancellor, sir, the Deputy Vice-Chancellor of Development, the Acting Registrar, the Acting Bursar, the University Librarian, Dean College of Physical Sciences, other deans and directors, Head Department of Physics, heads of other departments and units, members of the University Senate, all academic and non-teaching staff, all special guests and friends of the university, members of my family and friends, gentlemen of the press, distinguished ladies and gentlemen, great Funabites. Unraveling the coupled heat and water flow phenomenon, my non-invasive voyage into the subsurface domains. The overview of my presentation is as follows: introduction, preamble, contributions to knowledge, conclusion, recommendations, acknowledgement. Mr. Vice-Chancellor, sir, by way of opening, I stand here today to present my inaugural lecture as a professor of earth physics in the Department of Physics, College of Physical Sciences in this fabulous Federal University of Agriculture, Abeokuta. I joined the services of this university in 1998 as an assistant lecturer, and I rose through the ranks to the status of a professor, as said, on October 1, 2013. By now, I've spent 26 years in the services of FUNAP, but my presentation today will predate my joining the university system. A very brief history. This inaugural lecture is the second in the Department of Physics and is actually coming 6 good years after the very first. It's also the 7th in the College of Physical Sciences and the 89th in the university. The first in the Department of Physics, which happened also to be the first in the College of Physical Sciences, and the 56th in the university, was delivered on the 23rd May 2018. By providence, this 7th inaugural lecture is also coming in the month of May. Hence, in the College of Physical Sciences, this lecture is coming after those of Professor J.A. Olufela of the Department of Physics, Professors Eromasele Akinlabi and Dari of the Department of Chemistry, and Professors Akiwale and Shodia of the Department of Computer Science. This inaugural lecture presents a momentous platform to give account of my stewardship in teaching, research, innovation, collaborations, and manpower development before this distinguished university community and the general public. It is indeed a great privilege to present the 89th inaugural lecture of this awesome university, titled Unraveling the Coupled Heat and Water Flow Phenomenon, my non-invasive voyage into the subsurface domains. A simplified version of this topic would have been navigating the bowels of the earth to understand the water and heat transport systems with minimal physical contact. Mr. Vice-Chancellor, sir, permit me to do a quick introduction to the governing principles, summarize my scholarly contributions and human development efforts, and offer some short-term and long-term recommendations. I hereby request this distinguished audience to please sit back, relax, and join me on this observatory cruise. Heat and water fluxes. Heat and water fluxes are two quantities which are very helpful to nature, but can be unfriendly if they are not well understood and properly managed. We have established 2 facts from the inspired canons of the scriptures. Number 1, in the order of God's creations, heat and water fluxes were actually the first 2 to be created. Number 2, in the beginning, God used water to destroy the then world in the days of Noah. And at the end of the world, God said he's not going to use water now, but he will use heat to destroy the entire earth and the atmospheric heavens. Which means that water at the beginning, then heat at the end. Then something must be extraordinarily phenomenal about these 2 physical quantities. Heat transfer is therefore the transport of thermal energy between physical systems due to a temperature gradient. And groundwater flow is the movement of water on the ground and mainly driven by the hydraulic gradients. These 2 physical quantities, of course, they are distinct, they are unique in their characteristics. But under the ground, they hardly go in different directions. That's why we call them coupled, because they are always coupled together. They go in the same direction and they are fused together. And we refer to it as a model couple, actually. Even though it's an inanimate couple, Human couples have a lot of lessons to learn from them. And permit me to share some of those lessons you can learn from this model couple. Number one is visible, while the other is feelable. One is an extrovert, while the other is an introvert. And as human couples, we can easily relate to that. Number two, one is very reactive, while the other is very regulatory. That's why if you have a very high temperature, and then you see a doctor, the first thing they're going to do is that they ask you to pour water on your body so that you can regulate the temperature. What does that mean? It means that when one is angry, the other actually tries to calm it down. Then one is very moody, emotional, anomalous, and temperamental. Actually, water is very moody, anomalous, and temperamental. And that is why it changes forms very easily from solids to liquids and to gases. While on the other hand, the other partner is rigid and inflexible. Again, we can begin to think about the human couples. Who is anomalous, who is inflexible, and who is rigid. Number four, one is very predictable, while the other is not. Actually, each is very predictable, and water is difficult to predict. And I must say this, even in our scientific discoveries, in numerical experiments that we have carried out, we have found out that it's not so easy to use mathematics and numerical experiment to describe the behavior of water as one would have done easily when it comes to the issue of heat. So water is not as easy to predict as that of heat. And again, it happens in the family. Some partners are very predictable, while others are not. Then one serves as a carrier, while the other serves as an enhancer. Again, we can think about that. We can relate to that very easily in a family setting. Then both of them are very lovely. I've studied them over the years. They're an interesting phenomenon. Without them, actually, there is no life. The two of them complement each other. They form very strong partnership. They form a very strong bond. And this is actually, according to my recommendation, the best couple for us to learn from. Now, one key word in my inaugural title is non-invasive. As earth scientists, we don't like to invade the heart directly for so many reasons. If you invade the heart directly, you are going to set in some perturbations that can create some unintended consequences. And even beyond that, it's practically impossible to get to the core of the heart using any instrument known to man because of the extreme temperature down there. So what we do is that we study the properties of the earth materials. The mechanical properties, the thermal properties, the electrical properties, magnetic, gravity, and seismic properties. And from these properties, we can now make inferences of the substructure, the interior of the earth. And so that's exactly what we do. Now, the heart crust is constantly subjected to some push and pull forces, which we call the stress. In response, the heart materials undergo wear and tear deformations, which we refer to as the strain as a result of the sudden release of energy. Now, this energy that is suddenly released moves from the place of release to the surface of the earth by way of seismic waves. And these are the waves that cause the heart to quake or to shake, as the case may be, when we experience what we call the earthquakes. And so they come out in form of seismic waves. And so what we have studied over the years is actually these seismic waves that operate in different places. And the seismic waves are actually of two types. The ones that operate in the body of the earth is called the body waves, and those that operate at the surface is called the surface waves. The ones that operate at the body of the heart, they are primarily two. One is P, or primary wave, the other is S, or secondary waves. Now, the P waves or the primary waves is very fast and is one to arrive much faster than the secondary waves. They also call the compressive and the shear waves, or the longitudinal waves and the transverse waves. Now, at the surface, you also have them divided into two. They are called the Rayleigh waves and then the Love waves. The Rayleigh waves are actually also of a combination of the P and S waves, and they operate at the surface. And these are the ones that cause the most devastation that you see in the process of an earthquake. Mr. Vice-Chancellor, sir, this is the slice picture of the interior of the earth. The center of the earth is called the core and is divided into two: the solid inner core and the liquid outer core. The core is actually about 6,000 kilometers deep and also about 6,000 Kelvin in terms of temperature. Interestingly, it's about also the temperature of the surface of the sun. And that gives us an insight into the volume of geothermal energy potentials inherent within the subsurface structure. And of course, the principle is very clear. Down there, temperature is relatively constant along a particular horizontal profile. But of course, it varies depth-wisely. Unlike what happens in the upper and the lower atmospheres. Down there, the temperature doesn't change as much as it does in the upper and the lower atmosphere. And of course, the reasons are very clear. So what happens is that the depth-wise change is what we call the depth-wise variation, and is the one that yields the geothermal gradient. And the geothermal gradient is the one that yields the heat flux, which I will talk about. And of course, the heat flux now is the one that delivers the electricity generation, which we as a nation now, we can begin to think about it. Other countries are looking at it very critically, but we in this country, we have not set up a enabling environment and then sufficient legal frameworks to be able to support it. And that's why we are trying to contribute to the narratives of geothermal energy. But I see a paradox here, Mr. Vice-Chancellor. And what is the paradox? The most common belief is that the center of the earth is a place for afterlife. The ancient Greeks, they call it the underworld. Some Hebrews, they call it Sheol. And some religious scholars refer to it as hell. Hell is therefore usually referred to somewhere down below. As a matter of fact, when you look at the inspired canon of the scriptures and you look at the phrases that are associated with somebody going down to the abyss, you see things like descended into, or went down into, or thrust down into, or great depth, or from beneath, or lower parts of the earth. These are things that we hear when it comes to talking about somebody descending to the abyss. There's therefore a very strong convergence of opinions that Sheol or hell is an extremely hot place that is located somewhere down below and burns continuously with an extreme heat. And of course, it burns with sulfur and brimstone. What then is the paradox? The paradox is this. The subsurface is actually associated with something hellish or something negative. But on the other hand, it is the single largest repository of the natural resources ever known to man. And of course, God has designed it so for the wealth of the nations. So on one hand, it looks as if it's a negative. On the other hand, it has a whole lot of positives. And that's where I see the paradox. And of course, this paradox is what we are still looking at, and we keep exploring it as time goes on. Of course, the basis for this is not unclear. We all come from it as creations, and of course, we are going to return back to it. And when we return back to it, we undergo all kinds of transformations, biological, chemical, physical. And these are the things that make up what we call the natural resources. My contributions. I will discuss my contributions under 7 areas. The first one, I want to look at the models that we have developed over the years. I call them numerical models. Number 2, there's some of the measurements that we have made. The ones that are notable among them, I call them noteworthy measurements. That's number 2. Then, of course, we have also developed some methods over the years. I refer to it as novel methods. And of course, we came across some materials which are very useful in the understanding of earth sciences, in a search of our looking for materials that can solve these fundamental problems. And I call them normalizing materials. Of course, because the equipment that we use in earth science are very expensive, they are not easy to come by. We have also developed some new meters which we can use to make some measurements. I refer to it as new meters. And of course, we never did all of these things alone. We have been lucky to have the brightest of students to work with, and I refer to them as next generation manpower. I'll talk about them very quickly. And of course, I've worked under several eminent personalities in this country, in some national committees, and that's why you see the array of the best of men in this garden today. And of course, in those committees, we have been able to develop some manuals which the country is looking at, and I refer to it as national manuals. So numerical models, noteworthy measurements, novel methods, normalizing materials, new meters, next generation manpower, and I talk about manuals. Mr. Vice-Chancellor, sir, the first one is numerical methods. Now, between 1996 and 2004, we adopted a non-invasive approach, and that's very clear. I knew we were going to do that because from the keyword in my title, we knew we are not going to do a lot of invading the heart. So the best thing to do that is to use a lot of numerical experiments. So we carried out a whole number of numerical experiments to track the movement of contaminants in groundwater. In Oluwafemi 2001, Akinyemi and Eto 2003 eventually developed 2 models. The first one is the one that predicts the fate of a migration of contaminants in groundwater. When you see a contaminant that has hit the groundwater system, so that model can track the fate and the migration of that contaminant, and then you can design appropriate containment strategies and appropriate remediation approach. And that's what the model talks about. Then number 2, the model talks about vertical diffusion of contaminants in groundwater. essentially the same thing. When you now have the one that is landing on the groundwater, and you know some properties about that contaminant, again you can design, you can look at the vertical diffusion, and again you can look at some appropriate remediation processes, which is the most important thing. So all of these things happened between 1996 and 2004. Now, on the strength of that, I joined the Global Earth group through a postdoc fellowship between 2007 and 2010. And the objective of that Global Earth group was to simulate fluxes within the subsurface, heat fluxes and water fluxes. And we did that so that we can design appropriate underground heat tanks because of the volume of geothermal energy inherent within the subsurface. So we can sink the underground heat tanks, absorb some geothermal energy, and use them for household use. And that's the purpose of that group. That's what we did there. Fundamentally, we relied on the model of De Vries 1957 in that program, and then Philip and De Vries 1957. And then Akinyemi et al. 2007A, 2008D, Akinyemi and Mendes 2007, 2008A, and 2008B. Introduced a mathematical model that linearizes the vapor-giving time exchange at the boundaries. Then we developed a numerical algorithm that simultaneously solves the governing equations at each time step. Of course, we look at the Earth as a block, and we look at the point of interest as very minute compared to the surrounding medium. Then we saw that the surface of the Earth is exposed to the atmospheric variables, principally the long and short wave radiations. And then we saw that the other 5 surfaces of the block, because of the minuteness of that surface, we consider them to be impermeable and adiabatic, and it was safe to do that because of the size of the interior. Then, after doing that, we overlooked the convective heat transfer within the pores, radiative heat transfer within the pores, as well as the sensible heat transfer by the liquid and the vapor phases. Then we came up with a code using the MTDMA, multi-diagonal matrix algorithm. And of course, we tested the code. The code was fast, robust, and stable. And we're excited that indeed the job was done. But we needed to test the strength of that code to carry out some experimental work and compare with our numerical experiment. So what did we do? We took some flux probes, heat flux probes and water flux probes, and buried the probes within the earth. From the top, from the surface of the earth, of course, and several meters down. And then we are checking the flux. We allowed it to equilibrate for 3 months, and we left the experiment there for a whole year. And we're gathering the data, very huge data. And of course, while that was collecting the data, we stayed in the offices and we were simulating the entire depth where we were collecting the data from. And the idea is that, and that's where we are going. Instead of carrying out physical experiment, we want to do it numerically. And so we gathered this huge data and we simulated the data also. And now we compare the numerical experiment and then the field experiment. And those are the 2 top figures that you see at the middle there. One for the heat flux and the other for the water flux. What did we see? We saw a very huge agreement between the numerical experiment and then the field experiment, and we're excited. Of course, we noted some points of disagreement, especially down below. We also noted that water had more disagreement than heat. And of course, it's not unexpected because of what I said earlier, that water is anomalous, is moody, is temperamental, and is emotional. And so it's a little bit difficult to simulate experimentally. So we noted some of those observations there. And then after testing that, we now came up, we saw that there's this agreement. Then we now needed to simulate some cities remotely without going there. And there are some cities that are normally used to simulate numerical experiments. Because when you want to simulate numerical experiments, you go for cities that have complicated weather parameters so that you can check the robustness of that code. So what did we do now? We settled for a place called Seattle in North America, which is spontaneous and extremely cold. When we came to South America, we settled for another city called Curitiba. Curitiba is an interesting place because normally you have the 4 seasons there. You have the winter, you have the summer, you have the spring, and the fall. But in Curitiba, interestingly, you can have all the 4 seasons in one day. You can have the winter in the morning, you can have the summer in the afternoon, and then you can have the spring in the evening, and you can have fall in the night. So we normally use such kind of cities to test a numerical experiment. Of course, we went to tropics, and we simulated also Johannesburg, Asia, we went to Singapore. So we simulated these 4 cities just to test the robustness of our code. And we're quite excited that the results that we got, actually, they are not far from what happens in the reality. So all of these things happened between 2007 and 2010. Now, I told us that there were some points of disagreement, and these are still works in progress. This happened between 2012 and 2015. Mendes et al. 2012 found out that the disagreement that was seen, especially in the water profile, was because precipitation was not captured as a boundary condition in the numerical code. And we tried to do that actually, but we were having convergence problems. That's why we stopped. But now we needed to use precipitation as a boundary condition. What did we do? For us to do that, we had, so Mendes et al. 2012 compare the water flux due to water gradient and water flux due to temperature gradient. And they found out that the water flux due to water gradient was actually far more influential than the water flux due to temperature gradient. And of course, and that was the game changer. Then that gave us the impetus to now decouple the equation. We divorced this model temporarily, and then concentrated on the water part component of the model, and then we simulated it again, and lo and behold, we're able to solve these problems of disagreement, and then we obtained outstanding results going forward. Now, Alabi et al. 2017 and 2018 generator water profiles using two approaches. The first one is the water balance, and the second one is the regression approach. This happened between 2017 and 2018. Of course, the water balance approach used air temperature as well as precipitation as boundary conditions. But the regression approach uses water content, of course, at the surface to estimate the water content down below. Of course, they compared the two and found water model to be far better than the regression approach. Now, I told us that we also did some noteworthy measurements. That's number 2. Now, Oluri et al. 2015 A and B carried out magnetic intensity investigation using aeromagnetic studies. The objective was to advance narratives around geothermal prospecting. I kept talking about geothermal prospecting because that's the real thing there. What did we do? We digitized aeromagnetic data for both sedimentary basins and then the basement complex. For some cities in the southwest here, we collected aeromagnetic maps and digitized the maps and of course got this data. Then we determined the magnetic intensity and then depth to basement sources across the southwest. The reason is that from these sources now, we can pull up our query point depth, we can pull up our geothermal gradient, we can pull up our H flow, and then we can also now contribute to the narratives around the geothermal energy, which we are now trying to push as one of the reasons that Nigeria can go into. As a country, we have been talking about renewable energy over the years. And when we talk about renewable energy, the only thing we have been mounting over the years is solar, as if solar is really renewable energy. Not knowing that there's abundance of energy lying under our feet. And this is one thing that we can use as a nation, even at a regional level, and absorb them for household use. And that's why we are doing experiments around some of these things. Now, Akinyemi et al. 2012 A, B, C, D, and E, 2023 A. Uruni et al. 2012, Badmos et al. 2013 B, Kufariji et al. 2017, 2021, carried out in situ and ex situ classification using lab and field experimental profiling. The objective was to delineate minerals, both in the laboratory and then on the field. And so we got a lot of earth materials across the southwest and even beyond. And we carried out a whole lot of tests, electrical tests, mechanical tests, thermal tests, seismic tests on all of these materials. And we invested a lot of data, big data actually, which we now use to delineate the mineral compositions of those earth materials. For example, let me just share some of them. We found out that electrical resistivity ranged between 6 and 171 kilo-ohm meter. We also found out that permeability ranged between 1.47 and 7.99, and then the porosity from 0.03 to 0.64. We went on the field also using our geophysical methods and did all of this mineral prospecting and found deposits of minerals all over in the southwest here and beyond, which you can even rely on as a country. Then number 3, Oluwafemi et al. 2012 B and C experimented on landfill contamination tracking using EIT imaging. EIT is electrical impedance tomography. And the objective is to determine safe windows for groundwater. It's many of us, especially in the southwest here, our residential buildings are located near dump sites. And the question is, what is the safe window between your residential building and a dump site? And that was the question we're trying to solve. And we tried to do that using this EIT imaging. Of course, we tested a whole lot of dump sites across the southwest, but I'd like to share just some of them. We investigated Abule Egba dump site, which was established in 1982 as a 21 hectares dump site. Then Alimosho 1 dump site, a 7 hectares dump site. Alimosho 2 dump site, a 4 hectares dump site using this AIT. EIT is just an approach that arranges the electrodes in circular form. Then current is injected into the ground. And of course, the impedance tomograms is pulled up so that we can see the movement of the contaminant plumes under the ground below the dump site. And we can see how it is moving and how it is entering the residential places. And that was exactly what we did. And we found out that in some cases, the contaminant plumes had migrated about 200 meters away from the base of the dump site into the residential buildings. So what's our advice? Our advice is that when you are locating your residential buildings, watch out for the dump sites around you. If not, you'll be drinking contaminated water. And we advise that you stay away from it at least for about 1 kilometer. Of course, plus or minus. It's also a function of the age of that dump site. It's a function of the size of the dump site. It's a function of the materials that make up the dump site. But putting all of these things together, please stay away from the dump site, because even though you are safe, your gate is there, but your groundwater system is not safe because contaminants are going into your groundwater system and to impact on your health. This is very important. Then number 4, Akinyemi et al., Olabode et al. 2021, and then Folani et al. 2023, work on groundwater tracking using ERT imaging. And then the objective was to map saltwater intrusion. We are having cases of high blood pressure, and then hypertension cases and all of that. And then there are so many reasons why that is happening. But we're also suspecting that there's groundwater intrusion from the sea into there's saltwater intrusion from the sea into the groundwater system. Normally, the seawater is salty. And so it goes in there, and we were trying to track the pathways. So that was exactly what we did. And most of our cities in the southwest, they are coastal cities. So evidence of intrusion is there. Saltwater is intruding into the groundwater system. And so we carried a lot of experiments using some coastal communities, and we found evidences of saltwater intrusion. There is a reason why it intrudes. There's an hydraulic connectivity between the groundwater and then the seawater, and that's why saltwater moves very easily. So we found low resistivity structures, generally between 20 ohm meter, which shows there's evidence of saltwater intrusion. We carried out a seasonal variation, and we found out that the intrusion was more in the dry season than in the wet season. And so what's our recommendation? If you have a borehole in your house and you are drinking the borehole directly, please once in a while carry out tests on the borehole. If not, you will be sinking a lot of salt water into your body and to impact on your health. And I also want to say that you emphasize more during the dry season, because that's where we saw the spikes there. And the reasons are also not far-fetched. In the dry season, there's pressure on the aquifer, and then there's also over abstraction of water from the underground water resources. And so please, this is our recommendation. Then Babatunde et al. 2016 carried out oil-bearing formation testing using petrophysical analysis. The idea was to optimize the efficiency of these oil-bearing formations. Oil-bearing formations include things like shale or limestone. So we collected some of these materials in the southwest, and then we arranged them under different configurations. And then we have some equipment to introduce some ultrasonic signals, and then we measure the VS, the petrophysical parameters, the shear wave velocity, compressive wave velocity, the Poisson ratio, the elastic modulus. We measured all of these things at 40 and 50 kilohertz frequency and 50 megapascal. Then we determined the petrophysical parameters, and we found out that 21% of clay content will impact on the elastic modulus of limestone, and 23% of clay content will impact on the elastic modulus of shale, and that was quite very significant, especially in oil and gas industry. We also found out that porosity has more influence on the wave velocity than the clay content for both limestone and shale. Then we carried out compressive temperature coefficient. We took the samples and burned the samples from 50 degrees to 300 degrees at intervals of 50 degrees. And of course, we introduced the ultrasonic signals again, and then we collected the petrophysical parameters, but this time around at 0.01 gigapascal. Then we found out that elastic modulus is directly proportional to the compressive wave temperature coefficient, and also the density, while porosity is inversely proportional to the compressive temperature coefficient. Number 3, we developed some novel methods. Olukayode et al. 2010A and B, Akinyemi et al. 2013B, worked on subsurface forensic imaging. This is very interesting because the objective is to develop some simple and inexpensive methods to image the near surface buried objects. Before now, the emphasis has always been on buried mines at the surface, but I tell you, that's not the issue now. In our country now, people now bury all kinds of things. People bury parts of human beings, they bury cash, they bury weapons, they bury money, they bury jewelries, and most of these things end up in the law courts. I'm happy that we have a senior advocate of Nigeria in the house. And so most of these things end up in the law courts. And most of the time, the opinions of the ex-scientists are sought to give their expert opinions in the law court. So we felt that, and if you want to carry out some of these images, You have to use things like IR cameras or things like a ground penetrating radar. And these things are not easy to come by. So we felt that what can we do? And there's a simple science that these materials, when you bury them under the ground, they normally emit radiations. And then you can now use the temperature profiles of these radiations and then develop what they call the thermal fingerprint. And that was exactly what we did. Very simple, inexpensive. And again, this material, so what we did is that we buried all kinds of things under the ground, all kinds of things. Then we harvested their temperature profiles to now develop the thermal fingerprints. Again, we passed electromagnetic into them, knowing fully well that there will be attenuation of those energies so that we can develop the Q-factor fingerprints. So what that simply means is that if you can have some simple machines that can measure temperature profiles, if you are suspecting that something is buried somewhere, just pick the temperature profiles and then compare it to the thermal fingerprints or the Q-factor fingerprints, and it will tell you to a very large extent how what is buried there. But let me also advise us that if you live in a house or in a property and you're not sure what is there, you find out that there's a particular part of the wall or a particular part of the floor is usually having a very high temperature compared to the surrounding, or usually low temperature compared to the surrounding, then you have to suspect that something is there. What is there may range from criminal things to non-criminal things. You may be lucky if it's non-criminal, because when you get to law court, ignorance is not an excuse. So it may be things like broken pipes or dead animals, but it may also not be that. It may be criminal things. That's why we say that when you see such things, you have to call for help immediately so that people can assist you to know what is there. What is there may be anything that can also implicate you in the law court. Now, Akinyemi et al. 2022 worked on building failures prediction, especially in the city of Lagos. We wanted to find out what is making these buildings to collapse every time. Every time. You have cases of building collapses. We know buildings can collapse for so many reasons, ranging from unprofessional practices to dishonest practices. But we are looking at buildings collapsing as a result of substructural defects, which you can actually have control over. So we worked over Lagos State. We worked with the Lagos State Building Control Agency. We worked with the Lagos State Material Testing Agency. We worked with the Lagos State Ministry of Environment, Ministry of Works. And then we had access to buildings which have collapsed and buildings which were about collapsing. What we wanted to do was to find common patterns in the subsurface structures of all of these collapsed buildings, so that we can predict to a large extent of accuracy that some of these buildings can collapse. And we did that actually. We went around the entire city of Lagos, used some of these buildings, and wired the subsurface of those buildings both electrically and seismically. They will pull up the electrical resistivity profile as well as the VS profile. And we indeed found field vulnerability patterns, which was our objective. But that was not a catch. That was not where we are going actually, even though that was the objective. We felt that was too laborious. Carrying big machines all over places like Lagos, complicated terrains, security issues, carrying our seismometers, our thermometers all over the places. We felt that can we develop some simple experiments? And that was what we did. We now took some of these profiles at some meters down, and then we took them to the laboratory, and we determined the electrical resistivity profiles, which we have determined on the field. We determined the shear wave velocity, which we have determined on the field, and we compared the results. And that was the exciting part of the experiment. And we found out that easily we can do that in the lab without going all over the field and doing all of that, even though we found what we call amplification factor of 4.13. And that was very exciting for us. Now, Akinyemi et al. 2011, 2012F, 2013A also carried out thermal block method reactivation. The objective was to revisit the thermal block method that was earlier proposed in the 1960s. Now, this thermal block method was proposed in the 1960s, but it was abandoned and discontinued because of accuracy concerns. What did we do? We took the machine again as a collaborative effort between our team and a team in the USA. We assembled this machine again, tested it in Nigeria and tested it in the USA, and then identified the sources of inaccuracies, and we fixed the source of inaccuracy. Because when the person that developed the machine had been issue, we now changed the name of that method. We call it modified thermal block method. And that's what our group has done. You Google it now, you can see modified thermal block method, and that's a collaborative effort between our team in Nigeria here and then the team in the USA. Now, Akinyemi et al. 2023A and B also work on groundwater pollution aggregation, trying to develop a simple method to aggregate groundwater pollution indices. trying to compare level of groundwater pollutions across the geographical locations. So what did we do? This is something that is novel. That's why I call it novel methods. So we use multivariate analysis to be able to analyze for the different parameters, and then we came up with weights that can quantify the groundwater pollution indices so that we can be able to compare it across the geographical locations. And that was also a new method which we have released into the scientific committee, and they have accepted this, and it's working fine. Normalizing materials. There was a nagging problem that we had in the earth science circle, which is a problem of determining thermal properties very accurately. What we had then was that it's either the properties are overestimated or underestimated. And we're trying to solve this problem because it's important. Either you want to do field experiment or you want to do numerical experiments. You must determine thermal properties because there are three things that we normally use as input parameters: the sorption isotherms, the thermal conductivity, and then the transport coefficients. So thermal properties are very important, whatever you want to do in earth science. So but these parameters were not accurately measured. So, but we know from science that mixing compounds can actually take care of this problem at air-dry conditions and at saturated conditions. So with our team in the USA again, we carried out a lot of collaborative work, and then we tried to identify two heat-sink compounds. The first one is the active silver, and then the second one is the white grease, and we have successfully handled the inaccuracy that happens at the air-dry conditions. Akinyemi and Sawyer 2007, Akinyemi et al. 2007b. Meters. I told us that we also developed some meters. Equipments are very expensive, not easy to come by. So across the ways, we're also thinking of what kind of meters can we fabricate along the line. So there was this machine called heat-flux meter, which was developed in France. So it's a collaborative effort between France, America, and Nigeria. And then we carried out a lot of experiments to improve this particular device that you are seeing. Sawyer et al. 2008A, 2008B, now improved this particular method, and is now called perforated heat flux plate meter, which is now being used to measure thermal properties across the entire globe. And that's what we have done. Number two, Fasson et al. 2008A, determine or fabricated thermal properties meter. I told us about thermal properties because it's very important. So a collaborative effort between our team in Nigeria and another team in Canada. So we thought of what can we do. So we developed this particular simple device that can actually measure thermal properties with a high extent of accuracy, and is there in the scientific community and is working fine. Then Akinyemi et al. 2011, 2012A, 2012F, 2013A worked on the modified thermal block meter. I told us about the processes that went into the development of the thermal block meter, but this is now the machine itself that you are seeing live and direct. So this is what we have developed, and then it's now called modified thermal block meter, which we are now using to determine thermal properties with high level of accuracy. We never did all of these things alone. I said it before. We have had the opportunities of having worked with some brightest of students. The Vice-Chancellor said it in the citation that I've supervised, as a major supervisor, 9 PhDs till date. And I've also co-supervised 6 PhDs in my core area of research, apart from many other ones that we have done outside our core area of research. So, of course, many master's degree holders. So what you are seeing here, these are the 9 PhDs that you have supervised running around the earth and then contributing very significantly, expanding the frontiers of knowledge. 6 of them are in academia. 5 of them are in the universities today as lecturers. 1 is in the polytechnic. 2 of them are in the private sector. 1 is a lieutenant colonel in the military. Then apart from, of course, their names are there. And I also like to say that out of the 9, 8 of them are males and 1 is a female. I think she's around. Where are you? God bless you. So now, apart from these 9, the ones we have also co-supervised, I've co-supervised about 6 of them, and they are doing so well, and I'd like to mention them. Professor Bello is the Dean of Science now in Kashiore. Professor Ogungbe is around from the Lagos State University. I'm sure Professor Fagbo will be happy to see this. Immediate past HOD of Physics was also supervised by us, and that is doing so well. And many of them. And of course, our own dear Dr. Oluseun Oluni, doing so well. Thank you so very much. National manuals. I've had the rarest opportunities, because I would say I'm the smallest in these committees. As you have seen, these eminent personalities that are seated here today. I've worked in so many national committees, and we have developed some manuals, and I count those manuals as very significant contributions to the success of this nation. I've had the opportunity of working under Professor Emeritus or Emeritus Professor Femi Bamiro, under the National Research Committee. I will learn so much from him, and we developed the National Research Roadmap, which is now serving as a guide for the entire scientific community, education community in the entire country. And we are happy that we have contributed to that. We also served in the National TCO Operational Advisory Committee under Professor Adiza Galadanchi of Bayero University, Kano, and we developed the National TCO Blueprint, which is another significant contribution which is also being used all over today. I like to say also that in that committee, we have some juggernauts, some gurus who are here. I'm going to talk about them when I get to acknowledgement. Now, National Food Security Group, we worked also in this committee to develop the 2015 National Food Security Strategic Plan. This was under the chairmanship of Professor Mike Faborodi, who would have also loved to be here. I chaired that committee, and we developed this 2015 National Food Security Strategic Plan. And that's the plan now that is driving the 6th food security strategy for this nation. Many other people also contributed to that thing. Conclusions. Finding easier ways to unravel the complex interactions within the bowels of the earth is increasingly becoming important, not just because of the enormous resources lying beneath, but also because of the threats of contamination, as well as the danger of human clandestine activities. A major concern is getting the right mix of expertise and available resources to continue to carry out non-invasive studies. In the course of my voyage, I want us to listen to this. In the course of my voyage, I've had the privilege of working with some of the best minds, either as mentors or collaborators. I've worked in some top-notch laboratories, but there are some of my collaborators that I've never met face-to-face, even after many years of close collaboration. What does that mean? It means that the implication is that the whole research community does not need to relocate in order to collaborate. Earth science is a vast area that requires constant monitoring of activities through very expensive and large observation systems. A multidisciplinary approach through the power of simulation and field experiments using new methods and new measuring devices that are simple, affordable, and easy to use will be a viable alternative. Finally, the Earth system is one critical entity through which all other research areas within the field of science revolve. Hence, there must continue to be decisive and deliberate efforts from policymakers and researchers to ensure its survival, because therein lies our survival. Recommendations. I like to advocate for multidisciplinary research groups. Mr. Vice-Chancellor, sir. I like to advocate that mathematicians will form collaboration with nutritionists. I'm happy that the foremost professor of mathematical physics is here. So, and he will collaborate with what I'm saying. So, this is where we need to go as a university and as a nation. Physicists to work with animal scientists, mechatronics to work with plant scientists, and economics to work with environmental scientists. I also advocate for the creation of ideation meeting points where people from different backgrounds can meet to constructively interrogate research ideas, including students, with a view to come up with practicable solutions. The College of Earth Sciences, where all related disciplines in FUNAP can be warehoused, is overdue for consideration, either now or in the nearest future. I call on government to ensure targeted funding of exploitation of geothermal energy potentials as a viable energy alternative, better coordination of exploration of underground natural resources with robust frameworks and appropriate legal instruments, and improve synergy among researchers from military and non-military institutions. I want to believe that some of the officers of TED Fund are listening to me now online, because some of them are joining online. And I want to make this recommendation. We continue to appreciate the Tertiary Education Trust Fund for coming up with a 2 million marks IBR and a 50 million marks NRF. However, there's now the need for special funding for multidisciplinary projects to the tune of 500 million naira, which is about $400,000 in addressing some high magnitude national challenges. Acknowledgements. I thank my HOD, Professor Olukayode, other distinguished colleagues in the department, Professor Mustafa, Professor Badmos, who came from Ibadan today, Professor Adebayo, Professor Makinde, Professor Akilami, Professor Latishi, Dr. Akimboro, Dr. Alabi, Dr. Layade, Dr. Luni. Allow me to mention all of them, because these are my people in the department. Dr. Ganiyu, Dr. Adebambo, Dr. Egunjobi, Mr. Ajayi, Mr. Ishola, Mrs. Usidame, and all the supporting staff, Mr. Omigbenle and Mrs. Jeje. I acknowledge my Dean, Professor Akiwale, Deputy Dean, heads of departments, and other distinguished elders of the college, Professor IC and Professor C. Romosele, Professor Gutuashi, Professor Bangoshe, Professor Agbola, Professor Arobundade, Professor Adeniro, and many others. I appreciate the elders of the defunct corners, Professor Agbola, Professor Ashiribo, late Professor Ashiribo, Professor Ayodele, Professor Tokwe Kukola, Professor Akinloye, Professor Yabo Kehinde, Professor Ademiwa, and many others, Professor A.B. Dowu, and many others. Thank you. Now, Chairman of CODAT, Deans and Directors, Heads of Departments, and Heads of Units, thank you for the beautiful coup. They plotted a coup, actually, against me. That Committee of Deans and Directors. And I was asking that they give me time to deliver this inaugural lecture at a later date. But they insisted that I must do it now. And I pleaded, and they rebuffed my plea. And the masterminds of the coup are the chairman himself, Professor Showande, and Professor J.J. Atungu. They are the masterminds of the coup. But I thank you for the beautiful coup, actually. Kade's team, I will never forget you. Professor Fafiolu, Professor Adewumi, Professor Oshishino, Professor Balogun, Mr. Lanion, Mr. Okola, Professor Afolami. Thank you for coming, man, sir. Mr. Dr. Dada, Dr. Eden, Professor Puta, Professor Luatosi, Professor Daramola, Professor Bada, Professor Bayelu, Professor Adisa, Professor Adewumi, and many others. The DVC office, Mr. Adeshola, Mrs. Odubote, Mrs. Shonde, Mrs. Wachiku, Mr. Walker, Mr. Chima, and Mr. Salisu. The DVC facilitation team, Professor Idowu, Dean of Student Affairs, DDSA, Professor Gbeyale, Dr. Weto, Dr. Oluni, Mr. Shorichire, Mr. Yeloton, and Mr. Adeoshu. I give special honor to my academic mentors, late Professor Awele Madumezia, Professor Joseph Olufela, thank you very much, sir. A teacher, a guide, a trainer, and a leader par excellence. Professor Lukman Sumonu, Professor John Osemekian, late Professor John Osemekian, thank you, sirs, for seeing the light much earlier and believing in me. Your selfless investment to toil, to train, and to tutor us are deeply appreciated. I recognize the unquantifiable impact of my collaborators within and outside Nigeria. I've had the rare opportunity of working in national committees, many of whom are vice-chancellors, former VCs, and many others. Permit me to mention them: Emeritus Professor Oluwafemi Bamiro, who I refer to as Emeritus Chairman because he's chairing so many national committees at the same time. Professor Bisi Balogun, another Emeritus Chairman, who is chairing so many national committees at the same time. Thank you very much, sir. Professor Musa Kundiri, Professor Lanre Fagbon, Professor of Environmental Law and a Senior Advocate of Nigeria, former VC of LASU. Thank you so very much, sir. Professor Azam Bichi, Professor Shola Aderomu, Professor Emeritus Professor G. Ekaguri. Baba, thank you so very much, sir. A National Merit Awardee. And if there is somebody that will now get the Nobel Prize in Physics, this is Baba that will get it. Professor Abdullahi Zuru, Professor Musa Ebinu, Professor Olukoya Ogen, and then many others. I give special recognitions to my Lord's spiritual, Professor Egunjobi, and many other spiritual leaders that God has used over the years. Thank you, sirs. Dr. A.D. and Professor Tolu Enelonda, your prayers and supports have gone a very long way. We are indeed very grateful, sir and man. Dr. General Surveyor Banji Akinyemi and wife, they are somewhere there. We really appreciate you, sir. The Publications Committee, Mama Babatunde, thank you so very much. Former principal officers of the university, Professor Tayo, Professor A.R.T. Sholani. Baba was the dean, actually, when I joined the services of FUNAB. Professor S.T. Lagoke was director of Senhot when I was the assistant coordinator of pre-degree. Professor Onwuka, Professor Ariwo, I learned so much from them. Professor I.C. Remosele was the dean of the College of Natural Sciences when I was appointed the coordinator of the Department of Physics, and they provided a lot of guidance for me. Professor Arowolo was the DVC when we commenced the process of FUNAB Foreign African Scholarship Scheme for nationals of Gambia, Togo, and Liberia, and Sierra Leone. And that scheme was generously conceived by Professor Oluwafemi Balogun. Thank you very much, sir. Professor M.A. Wahid, Professor Remosele, these were the DVCs that I worked with very directly as DAP, and I learned so much from them. Mama is somewhere here. Thank you so very much, ma'am. I work with you so closely. I learned a lot from you. Sometimes you want to leave the campus and say, DAP, over to you. Just continue. Thank you so very much, ma'am. I appreciate you. And then Professor Dike Olu, Professor Sonny, I work with them. So many committees I learned from them. Professor Adeofun, chairman of our audit committee in the Center of Excellence. Professor Akedo Oluwale, Professor Sioni Kirby, very past DVC academic. Thank you very much, sir. Current principal officers of the university, Professor Adebayo, DVC Development, Mrs. Morufat Daudu, Mr. Olukayode Dewumi and Dr. Owolabi. Thank you, sirs and ma'ams. Current internal members of council, Professor Enshaw, Professor Adeoshun, Professor J.J. Atungo, Professor Fakoya, Dr. Duwole. Thank you so very much. Now, former vice-chancellors and current VCs. I salute the former and current vice-chancellors from Baba Adedipe to Professor Okoji, to late Professor I.F. Adu, and then to Professor Ishola Adamson. But I have special recognition for Professor Oluwafemi Balogun, the multi-talented architect of modern FUNAB, a God-sent instrument who through his master Google recognized my budding potentials, opened up opportunities for my skills enhancement, appointed me as the acting HOD, appointed me as the director of Senate, appointed me as director of grants management, and appointed. Thank you so very much, sir. I appreciate you. I would have given some stories, but there's no time. Now, Professor Oyewole appointed me as the director of academic planning. Thank you very much, sir. I must also talk about So I want to especially thank Professor Oyewole appointed me as DVC, DAP, and then Professor Eniko Main. Thank you so very much, sir. I must also make special mention of Professor Felix Kolawole Salako, who followed the footsteps of Professor Balogun in contributing remarkably and significantly to the infrastructure development of this great university. He summoned me back from sabbatical leave, and upon return, provided platforms for some other challenging responsibilities and development. I appreciate you, sir. I appreciate the current and seventh Vice-Chancellor, Professor Babatunde Kehinde, whose contributions to my personal, family, and career developments have been phenomenal, and who supported me to be the 9th Deputy Vice-Chancellor Academic. FUNAB has continued to grow in leaps and bounds with national and international accolades. Best University of Agriculture in Africa, 7th best in the world. And thank you, sir, for innovating this building in preparation for my inaugural lecture. My in-laws, Baba Ogushiji, Mama Ogushiji, Yinka is here, Fumi, Kemi, and Sheyi. I appreciate you all. My siblings, many of them, Professor and Mrs. Akinyemi, Chief Ogudare, Mr. and Mrs. Dako Akinyemi, Mr. and Mrs. Adekunle Akinyemi, Mr. and Mrs. Abiodun Akinyemi, Mrs. Foluko Akinyemi, Mr. and Mrs. Ademola Akinyemi, Mr. and Mrs. Kayode Ogushola, Mr. and Mrs. O. Williams, Mr. and Mrs. Bayo Akinyemi, Mrs. Kehinde Denike, and Mr. and Mrs. Olayinka. Thank you very much. I could not have asked for better parents. My dad, late Chief Isaac Ade Akinyemi, a disciplinarian to the core, who inculcated in us the values of integrity, good name, godly character, faith in God, and hard work. Continue to rest in the bosom of your Lord. My late stepmothers, we can never forget your labor and motherly care. My mom, Mrs. Felicia Adoyin Akinyemi, an epitome of virtues, godliness, sacrifice, love, hard work, humility, and motherliness. You remain the best mother in the world. Beautiful, even in your 90s. Thank you very much. Special gratitude to my children, Oluwanimlo and Enelua, and then the twins, Mololua, Mogolua. Thank you very much. And to the special one, the Honorable Minister of Home Affairs, the Honorable Minister of Stomach Infrastructure, Our Excellency, Dr. Oluwafemi Akinyemi. Thank you so very much for all your care, support, and prayers. Now unto the King eternal, immortal, invisible, the only wise God, the honor and glory forever and ever. Please join me to sing this song. This is my story. This is my song, praising my Savior all the day long. This is my story. This is my song, praising my Savior all the day long.
Please, you may have your seat. You may have your seat. Wow, what a day. A round of applause once again for our inaugural lecturer, the 89th Inaugural Lecturer of the Federal University of Agriculture, Abeokuta. Thank you so very much. I believe it has been worth the while of every one of us here. Once again, Professor Olukayode Dewumi Akinyemi, I want to thank you and appreciate you. Please, I will still ask that you stand up and come beside me here. I'm presenting this plaque, award of honor, to Professor Olukayode Dewumi Akinyemi as the 89th Inaugural Lecturer of the university, dated this day, Wednesday, 8th May 2024. Congratulations. You may not sit down yet. Don't sit down yet. Well, Professor Akinyemi did not invade the subsoil, but in our university, unavoidably, we invaded the soil. And after the invasion, we brought some products forth, and we are glad to present those products to you. These are products made in our university. So, on behalf of the university community, we present this to you. Thank you so very much. Thank you very much. It's been a day, and I want to appreciate everyone. The inaugural lecturer has actually acknowledged and appreciated almost everyone. But just for me to once again thank all the eminent personalities who have found it worthy to join us at this occasion. We want to thank you so much. We want to appreciate you, including the former principal officers of the university. We want to thank you so very much. And all members of the physics department, we can see you in your attire, members of COLPHYS and other dignitaries. We want to thank you so very much. And on this note, please permit me to also acknowledge a few more people. Professor Sam Otubushin, I learned is somewhere here. Professor Otubushin, an elder statesman from our university. Thank you, Professor Ikeobi, former DVC. We thank you so very much. And all other eminent people who are so many, so numerous. And of course, we appreciate you for joining us. We don't normally keep late, we keep to time. And so, we have come to the end of the 89th Inaugural Lecture of the Federal University of Agriculture, Abeokuta. We thank you so very much for joining us, and we hope you'll join us for the 90th Inaugural Lecture. Thank you very much.
Thank you very much, sir. A round of applause for the Vice-Chancellor, please. Thank you, Mary Obisted. Thank you, sir. Announcements, please. The academic procession will file out in reverse order through the central hall, yeah? While academic staff are to go through the exits A at my right, yeah? And the guests of the inaugural lecturer are to go through the exit B, right at my left. While students and others should remain in the gallery. Dear distinguished guests, ladies and gentlemen, it's now time for the anthems. We start with the Funab anthem, followed by the national anthem, which is the second stanza, and also the national prayer. Thank you. Second stanza of the national anthem. Thank you very much. Please, let's wait for the procession to file out of the hall before all of us will follow suit. Thank you. We have come to the end of the 89th Inaugural Lecture of the Federal. Okay. We've come to the end of the 89th Inaugural Lecture of the Federal University of Agriculture, Abeokuta. The lecture was titled Unraveling the Coupled Heat and Water Flow Phenomenon, my non-invasive voyage into the subsurface domains. We recognize the presence of the Dean of College of Animal Science and Livestock Production, Professor Olushi Gishowande, College of Plant Science and Crop Production, Professor Jonathan Atungu, College of Veterinary Medicine, the Dean, Professor Olushola Ajayi, Dean